We're going to look at sketching the graph of the derivative, or the graph of the derived function f dash x. The graph of the derivative is the gradient of the tangent to the curve, so it's all about the size of that gradient. Now, we've got two stationary points here. We've got one where x equals -2, I'm not interested in the y coordinate. I've got one here where x is equal to 3. So the gradient of the tangent to the curve at those stationary points is 0. Stationary points occur when dy by dx is equal to 0. So what you do is you take those stationary points and you drop them down onto the x-axis, because the y value there is 0, so the gradient of the tangent is 0. Now you know where that's occurring, so you know that that there is -2, and you know that one there is 3. X equals -2 and x equals 3. So that is the zeros. That's the gradient of the tangent is 0 at that point, and it's 0 at that point. Now we don't know the size of the gradient. We don't know the value. We don't know whether it's 2 or 3 or a half or whatever, but we do know whether it's positive or negative, and that's all we need to know to draw the graph. So we'll look at the shape of the graph here. That is increasing, so the gradient of the tangent to the curve that's uphill is always positive. Then it reaches 0, but then it starts going down, it slides down the way, so the gradient of the tangent all the way down there is negative. It gets to 0 again, and then it starts to rise, so it's positive in there. So any bits where it's positive gives me a graph that's above the x-axis. There's the x-axis. Any part that's negative goes below. But we've got another clue. If we have got two stationary points, then what happens is it reduces down to one stationary point. So this is going to end up as a parabola. So we'll now draw it. So what we've got then is we've got to draw the graph above the x-axis, so there it's above the x-axis, it's coming down to that 0. Then in between those two dotted lines, it's falling, so it's below the axis, but it's got to get back to itself, it's got to get back up to 0 at 3. And then after that line, it's above the axis, and that's the graph of y is equal to f dash x. Now, this one here, we've got two turning points again, there's one there and there's one there. So if we look at the gradient of the tangent to the curve at the stationary points, it's flat, it's 0, so that's 0 in there and that's 0 in there. So we take those zeros and we drop them down onto the x-axis, because that is where y is equal to 0. That's where the gradient of the tangent is 0. Now we can put the x numbers in, because I know what they are from that graph. So x was equal to 2, so that's 2. And then this one, x is equal to 5, so that's 5. We now look to see what's happening to this graph. So it's going uphill all the way towards that stationary point, so it's positive, positive, all the way up there. Then it goes to 0. Then it's negative in there. Then it goes to 0, and then it becomes positive again. So we're going to take all of that information and put it together. The other clue we've got is there's two turning points, so two turning points turn back to one turning point. So before we get to the dotted line, before we get to this stationary point here, we know the graph has got to be above the axis, and then it comes down at 2. But then I know it's got to go below the axis because it's negative there, but it's got to get itself back to 5. And then after 5, it's positive, so it's above the axis, and that's the graph of y is equal to f dash x. Okay, I should have written that in there as well. Next one. Again, we've got two turning points. There's a turning point there. That's the point 0, 7. There's a turning point there at 10, 0. So we know that the gradient of the tangent to the curve at a turning point is 0. So that's 0 there and it's 0 there. We're going to drop the zeros down onto the x-axis. So there it's there. And we know that that's 0. That one there will drop that one down, and I know the x value for that one is 10. So we'll put in those numbers. So that's 0 and that's 10. I'm now going to look at the shape of this graph. So it's going uphill, so it's positive all the way up there. So the gradient of the tangent is positive. We don't know the size, but we know it's positive. It then reaches 0 because that graph is flat there. And then in between the two stationary points, it is negative. It's going downhill. Then it reaches 0 again. and then it goes uphill. So that's our clues. But also, we've got two turning points. Two turning points change to one turning point. So I know I've got one parabola here. Now it's positive, so it's above the x-axis. It gets to that stationary point there. And then in between the two dotted lines, it's got to be below the axis, but it's got to get itself back to that 0 point. And then positive means it's above the axis. And that's the graph of y is equal to f dash x. Now, I've talked about if you've got two turning points, it changes to 1. If you have 3 turning points, it changes to 2. So this one here is called a point of inflection. Okay, it looks like the parabola has been twisted there both ways. Now, a point of inflection thinks it's better than a maximum or a minimum, and it classes itself as 2 turning points. So basically, it thinks it's 2 turning points, so when that's reduced, it goes to 1 turning point. So we'll look there, there's the gradient of the tangent is 0. So I'm going to drop the line, follow the same rules, drop that line right the way down and put that in there. So that is 0 in there. Now what's happening here? Before that, the gradient of the tangent to the curve is positive, it's uphill. But then it turns and it goes to 0, it's flat, and then the gradient of the tangent continues to be positive, so it's above the axis. So that means we've got a graph that's coming down, it's reaching 0, but then it's got to 0 and it's going back into the positive bit again, so it goes back up there and it turns, and that's the graph of y is equal to f dash x. So we had the 1 turning point, a point of inflection, but it thinks it's 2, so the 2 turning points effectively go to 1 turning point. Now we're back in this one to 2 turning points, but there are no points of inflection, it's just a minimum and a maximum. So we'll take the gradient of the tangent to each of them is 0, and that is 0. We'll look at the signs. So it's going downhill here, so it's negative. In between the 2 turning points, it's going uphill, so it's positive in all of those ones. It gets to 0, and then it starts to go down again. So we've got 2 turning points, and they go to 1 turning point, so I'd expect just a parabola. Right, so same rules, we'll drop the turning points down onto the x-axis, so that one comes down there, that turning point comes down there. So we'll put in the numbers for that, so that was at x equal to -3, that one was at x equal to 0. So what's happening? That is negative, so it means that the graph is below the axis. So on its way towards that turning point, it's got to be below. So we'll draw it below like that. It comes up and it meets that 0. Then it tells me between the 2 turning points it's positive. So it goes above the axis, but it's got to get itself back to 0. And then after that one, it's downhill. So it goes down like that. And that's the graph of y is equal to f dash x. Another one. We've got 2 turning points again. We've got a minimum. We've got a maximum. So we'll take those 2 turning points, we'll drop them straight down onto the x-axis. So there's that one comes down there, and there's that one comes down to there. We'll put in the x numbers because we know them. So that's at 0, and that one there is at x equal to, I think it was 2. To a check, I've drawn over it to see. It was x equal to 7. Right, so that's a 7 in there. Now, stationary points, gradient of tangent is 0. Stationary points, gradient of tangent is 0. It's a flat line. Here, it's going downhill, so it's all negative. And then after the turning point, it goes uphill, so it's positive. And then after the turning point, it goes downhill again. Now we're going to use a double check. There's 2 turning points. 2 turning points go to 1 turning point. So we should end up with a parabola when I draw this. So before the turning point, it's negative. So we draw it below the axis. Then it gets up there to 0. Then in between them, it's positive, but it's got to get itself back to 0. So we just take it into the positive bit above the x-axis and we bring it back to 0. And then at this x equal to 7, it's negative, so it goes back down like that. And that's the graph of y is equal to f dash x. Okay, here we've got it's also a point of inflection, so that's a stationary point there. So again, points of inflection thinks they're two turning points. So when we take the derivative graph, it's going to have one turning point. So what we're going to do is we're going to drop down the stationary point, and the stationary point is on the origin, so it's there at x equal to 0. So we'll fill that in there. And that's a point on the graph. Now it's falling here, so it's negative. So it's going down, it's all negative. It goes to 0, it goes flat, and then the gradient continues to go down, continues to be negative. So we know we're getting one turning point, so I've got to draw a parabola. I know before that dotted line it's negative, so it's got to be below the axis, so it does that, and it comes up and it reaches 0. But then once it gets to 0, it continues to be negative, so it continues to fall, and you get a parabola, which is a maximum turning point. So that's a graph of y is equal to f dash x. Another wee turning point here. So this turning point is sitting at x equal to 11. This 8 or negative 8, just ignore it. We don't need any y values. So we take the stationary point, we drop it down onto the x-axis because the gradient of tangent to the curve is 0. So that's 0 in there. Now, that is going to be x equal to 11. Now what's happening before that, it's going uphill, so it's positive. So that means that my graph has got to be above the x-axis. It continues to be positive at that part. Now, point of inflection thinks it's a two turning point, and it'll go to one turning point. So my answer is going to be a parabola. So we've got positive, means it's got to be above the axis. So I'm going to draw that above the axis like that, and it comes down and it reaches that 0 point on there. But then when it gets to 0, it's got to go back up into the positive. So it's got to go above the axis, and that is your graph, y is equal to f dash x. Now, this one here, we've got two turning points. We've got a minimum and we've got a maximum. So it's not points of inflection. So two turning points again, and two turning points will go to one turning point. So we've dropped the zeros down using our dotted line. So there's a turning point there that goes down onto the axis. There's a turning point there that goes down onto the axis. So we'll put the x numbers in. So that there has got to be -3, and that there is 0. So we know that the gradient of the tangent to the curve at that bit is 0. I know it's 0 there. I know it's falling all the way down there, so the gradient of the tangent is negative, so that means that part of the derived graph will be below the x-axis. Then it goes to 0, and then it goes up for that wee short time in there. Then it goes to 0 again, and then it starts to fall. So that means before the dotted line, it's got to be below the x-axis. So it's below the x-axis, so it comes up and it does that. It gets to the 0, but then it goes up into the positive, so it goes above the x-axis. But it's got to turn and come back to 0, so it comes up and it turns. And then after that, it's got to be negative, so it's down below. So we've got y is equal to f dash x. Okay, we're making these a wee bit harder now. So what we've got here is, we've got one turning point, we've got two turning points, and we've got a third turning point. So we've got 3 turning points, it drops 1, so it goes to 2 turning points. Our answer should have 2 turning points in it. So we've got all of those stationary points. Gradient of tangent to a curve is 0. That's stationary points, that's 0, and that's 0. So we drop them down because the y-coordinate is 0. So we drop them right the way down onto the x-axis. The y-coordinate is 0 there. We drop that one down, that's 0, and we drop that one down, and that's 0. So we'll put in our 3 points. So that one there, that one there, and that one there. We'll put in the x numbers. So that was -4, that is 0, and that is +4. We'll now look at the shape of the graph. So it's going downhill, so that's negative, negative, negative all the way down there until it gets to 0. Then it turns and it becomes positive all the way up there. Then it turns after the 0 and it becomes negative. It's falling downhill. Then it goes to 0 again, and then it becomes positive. So we know we're going to have 2 turning points, so we'll try and get that all pieced together. So negative means before the dotted line it's negative. So it's got to be below the x-axis. So it's going to come up and it's going to reach 0 there. Now in between these two dotted lines it's positive. It's got to get itself back to 0 again. So we just take it and we'll loop it round above the axis. Then we're at this bit, it's negative between here and the dotted line. But it's got to turn and get itself back to 0. And then after that dotted line it's positive, so it flicks above the axis. So we've got y is equal to f dash x, and our answer has got 1, 2 turning points as we expected. Okay, next one, we've got a maximum turning point and we've got a point of inflection. So point of inflection, that thinks it's 2 turning points because it's doing that and then it's turning. So effectively we've got 2 and that one makes 3, so we've got 3 turning points and we think that will go to 2 turning points. So we'll drop down the zeros. So there's my stationary points, the gradient of the tangent is 0 at the stationary points. So we'll drop them down onto the x-axis. That should be right on 0. That one is there. So that one should be at 0, it's a wee bit out. And that one should be at 3. So we'll look at the signs. So the top graph, we know that that's going uphill. So the gradient of the tangent is positive. It's uphill. Then we get to 0. The gradient of the tangent becomes negative. It's going downhill. Then it gets to 0 again because that's flat at your stationary point, and then it turns and it continues to go down. So it's got to be below the axis. So now, before this dotted line, I know it's got to be above the axis. So when I draw that, I've got a part of a line coming down and it's reaching 0. It gets to that 0, and between these two dotted lines, it's got to be negative. It's got to get itself back to 0. So then it's negative below the axis. It's getting itself back to 0, and that's it there. And then after this bit, it's got to be negative. So it's going to have to turn and go down into the negative bit. So that's your graph of y is equal to f dash x. And there you've got 1 turning point there and another turning point there. So we've got our 2 turning points in the answer. Next one, we've got no points of inflection. So we've got a minimum, we've got a maximum, we've got a minimum. So we've got 3 turning points, and we know that that drops down to 2 turning points. So that's my wee clue for the answer. Stationary points are turning points there, there, and there. So I know the gradient of the tangent to all of them is equal to 0. It's flat when I draw the tangent. So drop those lines down onto your x-axis. So that goes down onto there, that one goes down onto there, and that one goes down onto there. We'll put in the x numbers. So the x values there, that was -8. That one there is 0, and that one is 5. Graph before this turning point is negative. It's sloping downhill. So the gradient of the tangents are all negative right across there. Then it goes to 0, and then it goes uphill, so they're all positive in between those 2 turning points. Then it goes to 0, then it goes to negative, it's going downhill. Then it goes to 0, and then it goes uphill. So before this turning point it's negative, it means it's the graph is down below, so it goes up to 0 from underneath the graph. In between these 2 turning points it's got to be positive, so it's got to be above the axis, but it's got to get itself back to 0, so you just turn it back. Then between this bit and this bit it's negative, so it's got to be below the axis, so we take it below, but it's got to get itself back to that point, so we turn it somewhere. And then the bit after that turning point is positive, so it just shoots straight up like that. So y is equal to f dash x. Now we thought with 2 turning points, there's one there and one there, so that looks okay. Next one we've got here, we've got a point of inflection, and it's coming down there and it's turning, so that's a point of inflection. And we've got a minimum turning point. So the point of inflection thinks it's 2 turning points, that's 2, and that one makes 3. So 3 turning points drops, and it drops down to 1 less. It'll go down to 2 turning points in my answer. So we've got gradient of the tangent is 0 at that one, gradient of the tangent is 0 at that one. So we'll take our 2 lines We'll drop them down onto the x-axis because that's where the y-coordinate of the gradient of the tangent is 0. So that one there is at x equal to 0, that one there is at x equal to 5. We'll look at the signs. So that's negative towards there, so it's going downhill, that's why it's negative. Then it's 0. Then it continues to be negative between these two turning points, it's still falling. And then it gets to 0 again, and then it continues to rise, so it becomes positive. So remember, negatives are below the axis, positive are above the axis. So we know they're all turning points, they're all parabolas. So below the axis, we draw it like that. It comes up to that 0 point that we know is there. In between that 0 point and that one, that's negative. So it's got to go below the axis, so it turns and it goes below, but it's got to get itself back to the 0. And then after that, it's positive, so it shoots straight up like that. So y is equal to f dash x. We'll do a v-check. 1 turning point, 2 turning points. So that's okay. Next one, we've got 1, 2, 3 turning points. So the gradient of the tangent is 0 each bit there. So they get dropped straight down onto the axis. So right down there, a wee bit off the 0 there, and that one there, straight down. So we'll put in x numbers, minus 13, and that's probably supposed to be just 0, and that one there is 13. We'll look at the signs. So that is uphill, so the gradient of the tangent is positive. That means part of that graph is above the x-axis. Then it reaches 0, and then it starts to fall, so it becomes negative. That part of the graph has got to be drawn below the x-axis. Then it turns at 0, and it becomes positive. Then it gets itself to 0 again, and then it's negative because it's going downhill. Now we know that we've got 3 turning points. So when these 3 turning points, we've got the derivative of them, they change to 2 turning points. So that's another wee clue. So we've got above the x-axis before this dotted line, it's positive. So we draw above the x-axis, it gets to 0 there. Remember, these are all the zeros. Then in between these two, it's negative, so it's got to be below the axis, but it's got to get itself back to that 0, so we just turn it round. Then in between these two turning points, it's positive, so it comes up, and we just make it turn and come back to 0. And then after this turning point, it's got to be negative, so it shoots below. So the graph of y is equal to f dash x. 2 turning points, as expected. Next one, we've got 1, 2, 3 turning points again. There's no points of inflection, so 3 turning points will go to 2 turning points. We'll drop them straight down onto the axis. So the gradient of the tangent is 0, gradient of the tangent is 0, gradient of the tangent and that one is 0. We'll put in the x numbers where all that's happening. So it's happening at x equal to 0, x equal to 3 and x equal to 7. Before this turning point, the graph is going uphill, so it's positive. So that means the part of the derivative graph has got to be above the axis. In between these two turning points, it's got to be negative, it's going downhill. Then it gets to 0, and then it shoots and it goes uphill, so that's got to be above the x-axis. Then it gets to 0, and then it falls down again. So when we're drawing this, we're looking for a bit of the graph that's above the axis, going towards that point there. Then in between this 0 and 3, in between here, it's negative, so it means it's below the axis, so it comes below, but it's got to get itself back to 0. And in between these two bits, it's positive, so it goes up, but it's got to get itself back to 0 on that 7. And then after that, after this line here, it's negative, so it shoots down the way. So y is equal to f dash x. Okay, this is the last one. So the diagram shows the graph of y is equal to fx with a stationary point at -5, 8 and 5, 0. So the turning point, the stationary point there is a point of inflection. And it's turning, it's going down, and that's a minimum turning point, so 2 turning points. But that one, point of inflection, thinks it's 2, so 2 and 1 makes 3. So we've effectively got 3 turning points, and they're going to change to 2 turning points. We're going to drop them down to the x-axis because at a turning point, the graph of the derivative of the gradient of the tangent is 0. So that's why we drop them down. So the x number there is -5, x number there is 5. I'm going to look at what's happening here. So that's our zeros, it's flat, so there's no slope there, there's no slope there, it's 0. That's falling down, so that's negative. It's sloping downhill. Then it gets to 0, but then it continues to be negative, it's continuing to slope down the way. And then it gets to the turning point, which is 0, and then it starts to slope uphill. So we know we've got 3 turning points effectively, and we're going to 2. So this one here is negative, so it comes underneath the graph and it gets itself to that stationary point there where the gradient of the tangent to the curve is 0. Then in between these 2 turning points, it's got to be negative, so it's got to be below the axis. So I've got to turn it and get it down below the axis, but then get it back up to 0 again. And then after that 0, it's positive, so it's above the axis, so it shoots off like that. Doing these graphs, you need to practice them because it's dead easy to forget what you're doing. So I've covered all bases of them, so we've done every single type that you possibly could be asked. So just go over them, see if you can do them on your own, and see if you can get to a stage where you can do those questions without any help.